Oh, this is an interesting one, don't you think? We're taking the logarithm of a logarithm. Let's just work away from the inside out. So I'll bring this straight down. This will be the log of 3 of, all right, what have we got here? Log base 2 of 8. Now this is an exponent. What exponent are you going to put on 2 to get you to 8? Well, 2 to the third will give us 8, so this is a 3. And now we know this, right, because we have this fact, the log base b of b is 1, right? That's a fact. That the log of any base, if those match, you get a 1. That's what we have. The log base 3 of 3, so this whole thing here is equal to 1. Now again, in 77 here, we've got the log of a log. We've got a fractional base this time. Let's see what happens. I'm going to work from the inside out. The log base 1/2 of, okay, so what have we got here? The log base 3 of 81. So that's an exponent. Exponents go on bases. So I got to think, what exponent would I put on 3 to get me to 81? Well, 3 squared is 9. 3 cubed is only 27. 3 to the fourth takes me up to 81. So this is 4. Now I'm looking at an exponent again. So what exponent am I going to put on 1/2 in order to get me to 4? So I got to think about this one here. This is going to be 1/2 to some power gets me to 4. Now I know this. If I had some kind of a 2 up here, I could get a 4 out of there. What if I made this, okay, I would like to flip this fraction over, but if I do that, that's going to change the sign of that exponent. I have to know that exponent rule. So what I'm going to write here is a -2. Now if I did that, but let's be sure that that works. Remember, when you have a fraction to a negative exponent, you can flip the fraction over, but you have to change the sign of the exponent. Now that works, right? 2 squared is 4. I'm using this rule. We developed this rule a while back. If you have a over b to the negative n, you can invert that fraction, b over a, but you change the sign of the exponent. And that's what I'm using here. 1/2, I want to get to 4. So I know if I flip this over, if I invert it, I'd have to change the sign of that exponent. Again, let's start from the inside out. Now, the log base 6 of 6, those bases match. That's just a 1. So we're going to have the log base 3 of 1, and we already know that the logarithm of 1 to any base is 0. Let's start at the inside here. We've got log of a log of a log. So let's start with this one. The log base 2 of 16. What exponent are you going to put on 2 to get to 16? Well, that's a 4. So I'm just going to rewrite this whole thing here. We'll have the log base 4 of the log base 2 of, what did we just say that was? That's a 4, right? 2 to the fourth is 16. All right, now let's look at this one. What have we got here? That's an exponent. What exponent are you going to put on 2 to get to 4? Well, that's going to be a 2. So this is the log base 4 of 2. And now this is an exponent itself. What exponent are you going to put on 4 to get you down to 2? So it's down, so it's going to be a fraction. And you're probably thinking, okay, 4 to what power is 2? So if it was a 1, it would be 4. If it was bigger than 1, it would be bigger than 4. So what's it going to have to be? It's going to have to be a fraction. Now a fraction would be 4 to the something equals 2. And the denominator, all right, that's the root. The numerator is the power. So what root do you know of 4? Well, we know only 1, right? A square root. So if I take the square root of 4, I get 2. I just want it to the first power. So all in all, back up here, this thing is just equal to 1/2.